We are picking up our conversation on 6.5. So this is 6.5, day 2. Yesterday, the last problem that we worked through was H. And in this problem, we saw that when we FOILed, all of our radicals went away. The reason for that is because the two sets that we were FOILing were actually conjugates of each other. A conjugate has the same exact terms, just different signs in between. And we use conjugates to get rid of radicals on the denominator in this case. We've used conjugates in the past, complex conjugates, to get rid of I in the denominator, and now we're using them to get rid of radicals in the denominator. So we know that one of the issues or one of the conditions to be met for a radical expression to be simplified is that no radical can appear in the denominator. So when you look at this denominator, I see that I already have a radical, square root of 3 in the denominator. And you can't just multiply by the square root of 3 in the denominator to get rid of it. Because if you do that, you would have to multiply the entire denominator by the square root of 3. So I have seen many students try to do this to get rid of it. And what happens is you just move the problem from one term to the other. On the top, you would have 5 square roots of 3, and on the bottom, you would end up with 2 square roots of 3 plus the square root of 3 times the square root of 3 is the square root of 9, or just 3. So all we've done is transfer the problem from one term to the other. So that's not really going to work. Instead, we have to multiply by the conjugate. The conjugate in this case would be 2 minus the square root of 3. Because again, same terms, just a different sign in the middle. So we are going to take and multiply both the top and the bottom by the conjugate. 2 minus the square root of 3. 2 minus the square root of 3. So that means I need to FOIL the bottom. 2 plus the square root of 3, 2 minus the square root of 3. So when I FOIL this, I have 4, 2 square roots of 3, negative 2 square roots of 3, and negative the square root of 9, which you should be able to recognize as really just negative 3. So when I pull out of this radical, I have a 4, these are gone, minus 3. So on the denominator, I have just 1. On the top, I have 5 times 2, which is 10, and 5 times negative square root of 3, which is negative 5 square roots of 3. So my final answer is just simply 10 minus 5 square roots of 3. This meets all 4 of the requirements in order for a radical expression to be considered simplified. Turn your paper, and we are going to practice a couple more times. With J, I see that the issue that I'm having is that there's a square root of 3 in the denominator. So again, to get rid of it, because there's that plus sign, that plus 4, I can't just multiply by the square root of 3. I have to multiply by the conjugate. So I'm going to multiply both the top and the bottom by the square root of 3 minus 4. Again, same signs, same terms, just different signs in the middle. This requires me now to FOIL the top and the bottom because both the top and the bottom are 2 terms times 2 terms. So I'm going to set up 6 minus the square root of 3 times the square root of 3 minus 4 in a box. And I'm going to set up the square root of 3 plus 4 and the square root of 3 minus 4 in a box. And FOIL it out. So I have 6 square roots of 3 minus the square root of 3 times the negative square root of 3 is negative square root of 9, or just negative 3. 6 times negative 4 gives me negative 24. And negative 4 times negative square root of 3 gives me positive square root of 3. In the other box, square root of 3 times the square root of 3 gives me the square root of 9, which we know to be just 3. Square root of 3 times 4 is 4 square roots of 3. Square root of 3 times negative 4 gives me negative 4 square roots of 3. And finally, I have negative 4 times positive 4 for negative 16. Combine your like terms. Across the top, I have negative 24 and negative 3 for negative 27. And then I have 6 square roots of 3 and 4 square roots of 3. I know that these can be combined because they have the same index and the same radicand. So I have 10 square roots of 3. For the bottom, I have 3 and negative 16, which gives me negative 13. And across the other ones, they cancel. Now, when I look at this, I always want to be checking to see if I can reduce. And there's not a number that 10, 27, and 13 can be divided by. So I can leave it just like this. Or if you want to get technical, you can change some of the signs so that you don't have a negative on top and a negative on the bottom. But I would accept this as my answer. For the next problem, please remember, just like when we were working in the last few sections, what does it mean for something to be squared? And it means that that number or that term or that expression is multiplied by itself. So that means I have to use the box for this as well. Now, all of my radicals are not going to cancel out when I square because I'm not dealing with a conjugate. I'm multiplying the same thing twice. So I have the square root of 5 times the square root of 5. So square root of 25, which you should be able to recognize as just 5. Square root of 5 times negative square roots of 11 gives me negative square roots of 55. 5 times negative square roots of 11 gives me negative square roots of 55. And then finally, negative 11 times negative 11 gives me positive square roots of 121, which we should be able to recognize as just 11. Now we're combining like terms once more. I have 5 plus 11 gives me 16. And then I have negative square roots of negative 1 square root of 55 minus 1 square root of 55 gives me negative 2 square roots of 55. In the last problem, we should be able to recognize that this is one giant square root, and the issue with it is that the radicand is a fraction. So we are going to change this into two separates. And I can't reduce anything by a factor tree. So I need to focus my attention on what do I need in order to get the 5 and the y to come out of the radical. Since it has an index of 2, I need one more 5. Oops, that's multiplied. And I need one more y on the top and the bottom. So I'm left with the square root of 10y. And on the bottom, I have a 5 and a 5. Those can come out. And a y and a y. Those can come out. And this becomes my final answer. For the word problem, we have the area given to us in the base, and we have to find the height. Remember, we're going to use this formula. Base times height divided by 2 equals the area. So we're going to have a little bit of solving to do. So I have area is 189 plus 4 square roots of 3 equals the base times the height divided by 2. The first thing I'm going to do is multiply both sides by 2. So I have 189 times 2 gives me 378. And then 4 square roots of 3 times 2 gives me 8 square roots of 3. All right, now I have to be able to get the h by itself, and I do that by dividing. The issue that I have with my answer is that I have a square root on the bottom, so once again, we're going to multiply by the conjugate. Which means we need to FOIL. So I have 12 times 378, which is 4,536, negative 378 square roots of 3, 12 times 8, which is 96 square roots of 3, and then negative 8 times the square root of 9, which we know to be 3, so this whole thing equals negative 24. For the other one, we have 144 minus 12 square roots of 3 plus 12 square roots of 3 minus negative square root of 9, which we know to be 3. So we have 4,536 minus 24 gives me 4,512. Negative 378 plus 96 gives me negative 282 square roots of 3, and that makes up my top of my answer. And the bottom of my answer comes from my conjugate multiplied together. 144 minus 3 gives me 141. There's our answer.